All right, today's lesson is box plots, one of the most difficult graphs that we have at 6th grade. So let's get our target written down and our I can statements written down, and then we need to focus and get ready to go.
All right, first some vocabulary on how to build a box plot. A box plot is a diagram that is constructed using the median, which we know how to find, the first quartile, and the third quartile. So those are all the things that we were calculating in our measure of variations lesson. To create the box plot, a box is drawn around the quartile values. So down here, that's going to be my, here's my quartile 1, my median, my third quartile. That creates the box. And then we use our whiskers to connect out to those extreme values, our high and our low. So sometimes it's called a box and whisker plot instead of a box plot because you have the box and your whiskers extending out to the side.
All right, example 1. The list below shows a number of model airplanes owned by the members of the Aviation Club. Draw a box plot of the data. So your first step, you're going to order your numbers from least to greatest. So that would be 6.
So they already did that one for us in this one. It's already in order. So then first find your median in the middle. So you can use your little dots, kind of search your way towards the middle. Remember, you got to make sure you count off from both sides. But we get 11 as our median.
All right, here's where the fun begins. Now we're going to take everything between 6 and 10, which is the lower half of the data, and find the median between 6 and 10. That's called quartile 1, which is the median of the lower half of the data. That works out very nicely, so quartile 1 will be at 10. Then you go to the upper half of the data and find the median or the middle value of the upper half of the data. That's known as quartile 3.
Okay, let's go ahead and put those into our graph just to get us started. Put a dot at 11. Oh, that's out of 12, sorry.
And you're going to put a dot on quartile 1, which is at 10. And then a dot at 16, which is your quartile 3. After you make your dot, you're going to make them into, I don't know, hash marks.
Into your box.
And then connect the dots and make your box.
And then draw a line through your median there. So that's the box portion of it. Now we need to find those whiskers, those high and low. But one thing we have to watch out for is if we have any outliers in our data. If we have an outlier, we don't want to connect that to our box plot. It's too far away from the rest of the data. It's going to throw things off. So we kind of ignore that piece out there.
So Mr. McKenzie's going to look for the minimum value and the maximum value and put those dots on the graph. So he's going to put a dot at 6 and a dot at 27, the minimum and the maximum.
Now we have to go back and decide, do we want to include the 6 and the 27 in our box plot? To do that, we need to figure out if either one of those is an outlier. So if you remember from our measure of variation lesson, we find our inner quartile range. That's the third quartile minus the first. So 16 minus 10 is 6. And then we multiply times 1.5. So 6 times 1.5 is 9. So anything that's within 9 of our quartiles, we want to keep. So here are 16. If we add 9, that takes us all the way to a 25. Anything past 25 becomes an outlier. So 27 is our outlier. So we don't want to include that in our box plot.
So no straight line from your box to the upper extreme or 27.
So here we have 10 for our first quartile. We want to subtract away 9, and that takes us all the way down to a 1. So anything past 1 we don't want to include. 6 is fine. It's within that 1, or it's between our first quartile and 1, so we're okay there. That one we can connect together. But like Mrs. King says, we don't want to connect the 27, so we go to the next number on our line, which was our 18. We're only going to connect to that 18 because 27 is our outlier. And if you look at our numbers, it's pretty clear why 27 is an outlier. It's well away from all the rest of the data in the problem.
We have decided we are doing a box plot. I guess we don't have a title. So we're going to put them in order first. 3, 4, 5, 5, 6, 7, and 12. Now that we have the data in order, it's time to find the median. So crossing off or putting dots underneath to find that middle value, which ends up to be 5. Okay, 5 will not be included in the upper and the lower half of the data. So we're going to look at 3, 4, and 5 and find our quartile 1, which is 4, and our 6, 7, 12, and find the quartile 3, which is 7. Mr. McKenzie's then going to go down to his graph and put dots on 4, 5, and 7, and then connect his lines and make his box. All right, now we're up to that whisker pot. So we need to find the interquartile range. We've got 7 minus 4, quartile 3 minus quartile 1, giving us interquartile range of 3. He's going to go ahead and multiply that value by 1.5. Some of you are going to need your calculator. Some of you know it's 4.5. And then he has to go back to his data points. He looks at his quartile 3. Remember, you're going to add that 4.5 to that 7. He's going to get 11.5. And here again, we have an upper extreme, or the maximum, that is higher than our limits of 11.5. So he's going to put the dot of 12 on the graph to recognize that maximum value, but he cannot connect that whisker because it's more than 1.5 times the interquartile range. So he's going to go to his next data plot point, which is 7,
our 7,
and he already has a dot there.
There's no whisker on that side of the box.
Unbalanced. Go ahead.
Here we have quartile 1. We want to be within 4.5 of that. So 4 minus 4.5. That's going to take us into the negatives. So basically, as long as we have a positive number on our list, it's within our range. So our 3 is fine. So we put our dot at 3, and we connect that one to our box plot. Again, that 12 sticks out kind of like a sore thumb. It clearly doesn't fit with the rest of our data, so it makes sense that that would be considered an outlier.
Example 1 is done.
Oh. All right, example number 2. This one you're going to tackle on your own. So put the data in order, find your medians, your quartiles, your upper and lower extremes, your highs and your lows, create your box plot. We'll tell you in advance, this one does not have an outlier in it, so you don't have to worry about that. You can go ahead and connect the box to your high and your low value there.
When you're done creating the box plot, please don't forget about that sentence underneath that problem asking you to describe the data. Use your complete sentences and tell us what's going on in this graph. I know there's not a title, but do the best you can.
All right, so let's do the last one together. Okay.
Yeah. Putting the data in order. 104, 104, 106, 108, 110, 114, 120, 122, 130, and finally 140.
Getting close to our head there. All right, now we need to find our median, our middle number. So sort through your list, trying to find what's left in the middle. In this case, we have 2 numbers left in the middle. So this is where we need to find the middle of those 2 numbers. So if you're not sure what's in between 110 and 114, we add them up. And then divide by 2, and we get a median of 112.
This time, the fact that we have a middle number of 112 means that 114 will go with the upper half of the data, and 110 is going to go ahead and be included in the lower half of the data. So then he's going to go ahead and cross out high and low and find an interquartile range.
Or quartile 1
of 106. Sorry about that.
Okay.
And then the upper will get quartile 3 of 122.
So I'm going to go ahead and put those on our number line. You have to do a little estimating since all of your numbers aren't on the list. And then 122. Connect them to make the box and draw the line down for your median.
All right, so we have 104 and 140. as our extreme. So he's going to put those dots on, and then we need to decide whether they get connected to the box. So he's going to take 122 minus 10, does that say 106?
106, yes.
To find the interquartile range, which happens to be 16. Yep, multiply that by 1.5, and he should get 24.
So basically anything that's within 24 of our first or third quartile, we're okay with.
I mean, you can kind of spot it. You've got a dot very close to the box in the lower half, so we're more concerned with that 140 and whether that's going to be connected or not.
So this one's close enough. It's only 2 away from the 106, certainly not 24 away, so we're comfortable connecting that one. This one clearly looks like it might be a little too big. So we take our 112.
Or 122.
Oh, sorry. Our 122, our third quartile. We add 24, and that gives us 146. 146. 140 is within that range, so we're going to go ahead and keep that value. Is that true?
Mm-hmm.
Okay.
This is true.
In this case, 140, it looked like it might be an outlier for us, but it was within that range. It was within our 24 away from the third quartile, so we keep that data value. So your last step is go ahead and describe the data. What do you notice? Talk about where's the median in comparison to the rest of the numbers, how close are certain values to each other, or how far apart are they. Let us know what you know from this particular problem. And I think that's our last one.